Good morning.
Hello.
I want to thank everybody for tuning in today. For those that don't know me, my name is Tim Kelly. I'm the direct sales regional manager for the East Coast and Eastern Canada. And I'm joined today by Han Yan, who's our field applications engineer. Both of us work out of the New Jersey Service Center, and that's basically where we're doing this from today. Han, why don't you say hi to everybody?
Hi, everybody. I think some of you guys may know who I am, but for those who aren't, my name's Han Yan. Just like Tim, I'm based out of New Jersey Service Center as well, and I'm the technical guy here. So I'll be supporting your projects for modification stuffs.
Yeah, so today is our first stab at doing something live from New Jersey Service Center, so please have patience with us. Today's discussion, we're going to cover the autonomous mobile robot market. The reason why we picked this subject is because revenue right now is projected to hit around 14 billion by 2030. And from Meanwell's point of view, when it comes to keeping warehouse robotics running reliably, power isn't just an afterthought. It's the heartbeat of your entire operation. So Meanwell has really built a massive reputation in the automation world for delivering incredible, robust, efficient, and cost-effective power solutions. So whether you're designing a new automated guided vehicle, setting up an autonomous mobile robot fleet, or building out automated charging stations, dialing in the right Meanwell power supply or charger is the best way to prevent costly downtime and battery decline. Because warehouse environments today are notoriously tough, with fluctuating loads, tight spaces, and 24/7 demands, choosing the optimal Meanwell charger makes a huge difference in your customer's ROI and fleet lifespan. So with that said, why don't we kick this off, Han?
Yeah, so we want to start off with like what's the industry is like right now. So this is actually this animation you're seeing is a capture of our marketing team's job. They're going to be this is going to be published early next month. So basically, we're trying to let you know that for the robotic charging industries, we have humanoid, of course. You see, like maybe you have seen some big companies, they are like releasing some advertisements about like robots doing your housework. They're mopping for you, everything. This humanoid. And for like robotic dogs, you see like their dogs, they're carrying your like takeouts, they're carrying for the warehouse, they're carrying the pallets, the big shipping boxes. And also the other thing is like AGV, the automated guide vehicle. They follow you around, like, mainly in warehouse. They follow you around, so you can save. It's like replacing some of the forklift, so it's easier for the operators to carry around the ship to handle the shipments. And also like drone is, I think drone is kind of robot as well. It's a flying robot because like nowadays we know drone can do everything. So charging for drone is also a main topic like Meanwell does.
Oh, thank you for taking time to explain that. For the non-engineers in attendance, Han, why don't we kick this thing off with a basic question? What's the difference between a charger and a PSU?
Right. So first of all, like PSU stands for Power Supply Unit. I'm sure we are all aware of that. And power supply is like a general term. Everything is a power supply. A charger is a power supply because it supplies power. But what makes a charger different than the PSU is, first of all, charger has something called a charging stage. What that means is if you look at the PSU, you will see like, let's say, Meanwell LOP 424, it's 400 watt, 24 volt. And what it does is it gives you a 24 volt power source and it stays there forever. That's it. You take whatever current you need, but you always get the 24 volt. But for charger, it doesn't really work like that because batteries itself, they have some voltage on them. So in order for for a power supply or for a charger to charge it, your voltage need to be higher than the battery's original voltage, right? So we have something called charging stages. If you look at the slides right now, on the right side it says three-stage charging. On the left side it says two-stage charging. And the first stage is same. You see, it's called constant current stage, which means initially, if we hook up a charger to a battery that's nearly drained, it's going to like there's minimal energy in it, so we want to energize it first as fast as possible. So the first stage is the same for both two-stage and three-stage charging. It's going to push the maximum current from the charger, so push all the way into the battery to make sure, okay, the battery is rapidly energized, and that's the first stage. And when the battery's voltage reaches a certain level, okay, the charger knows it's time to make a change. So we cannot push this much current anymore. We have to stay at the exact voltage that I want the battery's voltage to be. Okay, so the charger will stay there forever. And then gradually slow down the charging current. So the current goes down, down, down because the battery's voltage is like slowly rising up. So the
Hmm.
actual difference is shrinking. Because the difference is shrinking, then the current will just drops. And here's when it makes a difference for two-stage and three-stage charging. For three-stage charging, after the current reaches a certain point, normally we say 5% or 10% of the rated current, the output voltage will change, will drop slightly by like 1 volt, and it stays there. It's called float volt. So this focused on lead acid battery because lead acid batteries they automatically like run out if you live there. So we need a small voltage applied between the terminals to maintain the actual voltage. So it's called float. But for the two-stage charging, actually, when the charging current drops to a certain level, the battery is almost full, and the charger just stop. And this refers to lithium-ion batteries because lithium-ion batteries are new and they don't discharge themselves normally. So two-stage is good enough. And this also the one important thing for charger to have is called constant current limiting, because for a regular power supply, if you hook up a battery to it, it will just burst whatever the power supply's got into
Right.
the battery,
Right.
and without limitation, it could either the power supply will be destroyed or the battery will be destroyed. So it's very dangerous. That's why the constant current limiting is a very important feature for charger. So yeah, the charging curves and constant current limiting, this was what makes charger different than power supply.
Okay. That makes
Mhm.
perfect sense. So this might be a silly question, but exactly what makes a smart charger smart?
Right, smart charger. So we always call our Mimo charger smart charger or intelligent charger, like the one you're seeing right now on the slides. There's HEP, there's MPB, and there's rack charger. And what makes them smart? So first of all, charging curve. But like I don't think it's worth mentioning because I'm sure all the manufacturers they know what charging curve is and they do charging curves. And what makes us smart is first is like say the communication protocol, because all the chargers we have they support either CAN bus or PM bus. So apart from the analog control where you have to give it like 0 to 10 volt or 0 to 5 volt, like an external analog source, it can be controlled digitally. All you need to do is send a command from a computer or like a pre-programmed PLC, so you can monitor the real-time status of the charger. Like what's the temperature, what's the current charge, what's the charging voltage right now, and what's the current, what's the output current. And if you want to make any adjustment, you're okay to do so. All you need to do is just type in some codes, or even if you have a UI with if you have a PLC with UI, just click something, and that's it. It's very simple. That's why that's the first thing we call a smart. It has to be digital. It needs to have communication protocols. And then the other special thing about our charger is we have the no battery detection. I think some of you might heard like from your end customer like why is the Mimo charger not charging? Like why there's no output? And they saw like there's something wrong with our charger. But no, our charger is being smart. Why? Because it does not see a battery at the output. And if the charger does not see a battery at the output, like upon startup, like what it does is within 5 seconds, the charger gonna shut down, like completely shut down. Because we do not want hot plug to happen. We don't want the customer to turn on the charger first and then hook up to the battery. Because what happens is when the charger is energized, when there are some energy, some voltages on output, and you hook up to the battery,
Okay.
like the second or the millisecond the battery is hooked up, there's going to be a huge current inrush, like a transient current spike that jumps up to, according to my experience, could be like a couple hundred amps. So like for a 10 amp charger, a couple hundred amp is too much. So the first thing is it could stress out the output components of our charger.
Hmm.
And it could also do some damage to the batteries too. Yeah, because that's what hot plugs does. So we do not want that to happen. Therefore, we have the shutdown protection. So like if in 5 seconds, no battery, no output. That's what we do. And the next thing is our chargers has Orin FET on the output. Orin FET is basically like anti-backfeed device. So we because the batteries themselves they carry some voltage, and we don't want something goes back from the battery to the power supply and the damage our unit. So we have Orin FET at the output to protect our units. And we have another fun fact about our power supply is actually all of them, all the chargers we have can be set to power supply mode. And all the smart chargers for GC30, like the very small charging adapter, maybe not, but like MPB, HEP for the big units, they support like switch between power supply and charger mode. So if your customer say, I want to charge batteries, but also I don't want sometimes I do not want the voltage to change. Like a charger, I want it to serve as a pure constant voltage power supply.
Right.
And yeah, actually we can do. So it's all you need to do is send a command using CAN bus or PM bus, and this can be done. We also have another series called MPP. You can do it via a mechanical switch. But for all other powers, for all our chargers with communication protocols, maybe you don't see this like in datasheet, but yeah, this is a secret function we have for all of our units.
Okay. Smart answer.
Yeah.
That's what I did there. So Han, for the folks here who are not battery literate, what's the mainstream battery types?
So right now for batteries, the mainstreams are still lead acid and lithium ion, and sometimes there's a sodium ion battery. It's
Okay.
kind of in between lead acid and lithium ion. So because like for lithium ion, we know it's been there forever. Okay, it's ultra reliable, it's cost effective, it's made of liquid sulfuric acid. So one thing is it doesn't burn itself. It doesn't go out of thermal like it's the thermal performance doesn't go out of control because it's liquid. Essentially, the liquids cannot be burned, the sulfuric acid. For lithium ion, it's much, much more power dense. If you look at the table right here, you will see like the cycle life, in terms of cycle life, lithium ion is much
Right.
more than lead acid. And for the voltage, because lithium ion is made of like each small individual cells, each cells are either 3.2 or 3.7, and so the increment is small. Unlike lead acid, like you normally see 12 volt, 24 volt, 36 volt, like 12-volt increment for lead acid. But
Gotcha.
for lithium ion, you can see like 58.8, 42, 30, some like weird voltages because the combination is flexible. You can
Okay.
just there's a 3.7 increment, and that's one thing about lithium ion. And sodium ion is very similar. And as for fully and also because lithium ion battery it requires a BMS, which is battery management system. Because for first of all, we know it's much more power dense. So, and by chemistry nature, it's much more dangerous. So we need something on terminals to keep it under control.
Gotcha.
Yeah, so we don't, but because of BMS, lithium ion battery doesn't normally, run out of battery charge by itself. But we must have a BMS on the lithium ion batteries.
Gotcha.
Yeah. And for the charging current, if you see the 0.1C to 0.3C, for those like who are not very familiar with what this is how we describe a charging rate. And using the simple term is you see a battery has amp hour. You times this number to the amp hour. That's the usual like charge current. For example, a 10 amp hour battery, 0.3C is 3 amp. And you see like lithium ion is much faster compared to lead acid, and sodium ion is kind of similar. And in terms of cost, of course, lithium ion is the most expensive, and lead acid is the least. And sodium ion is kind of in between, but I think it will, with the development of this technology, the price can eventually drop.
Okay. I got another question too,
Mhm.
just for maybe folks that really aren't battery literate.
Mhm.
Does the type of battery that the customer's using, does it affect the product that you can select?
Yes. So for batteries, like if you remember the previous slide, there's a charging curve. So for the two-stage charge, we use that for normally lithium-ion battery because, like I just mentioned, lithium-ion battery has BMS, which means the battery management system knows what to do. It takes control.
Okay.
So when the lead acid finish charging, you don't need to keep it float. You just shut down the power. So two-state charging. But for like lead acid without a battery management system, you need to keep the battery floating, like slowly charging. Like when you charge your phone, you see it charges to 80%, and the last 20% takes like forever to charge
Right.
because we try to protect the battery and also like slow charge it.
Gotcha.
Yeah, that's just a difference.
Okay. I appreciate
Yeah,
that.
problem.
So I noticed on this slide that you offering the UHP series and it's being called out. I noticed it's being called out quite a bit on projects that I work on too, in this particular space. Can you tell me why it's so popular? And in this case, also why it's being used?
Yeah, sure. So for this specific project, we used the customer wants to have a fanless unit
Okay.
because this goes to in warehouses as well as sometimes it goes to residents. So they don't want the user to hear noise.
Got it.
And also they need something works for 120 volt because in America, 120 is the residential grid voltage. So it has to be plugged. It can be used. But 120 gives you a D rate because 120 is really low. So a 2500 watts unit, eventually you get 14, 15, which is sufficient for this customer. So that's why we used it. And also for camp, UHP right now, we are standard. This is not a charger. You might notice this is a power supply. But for meanwhile power supplies, as long as they have CAN bus, they have communication protocol. For example, this unit has CAN bus. So we can program it using CAN bus. So
Okay.
we set a current limit. You cannot go over this. So with this current limit protection, current limit setting, you can use it as a charger. And also the output voltage can be changed in real time.
Okay.
So you can, if the battery's voltage changes, you can change it on your computer, on your programmer. It's very easy. And we have done some modifications to this unit too to make it happen because the customer is using a lithium ion battery. And I mentioned lithium-ion batteries are made of cells, there could be some weird voltages, and the voltage can go like from high to very low, unlike lead acid. So for most power supplies, when the voltage is dragged down to like 60, 70% of its original, the under voltage protection could be triggered. So the unit just shut down because the voltage is too low. But since this is for a charging application and this is a possible scenario, what we did is we made a customized firmware to lower the under voltage threshold so the unit can be used to charge batteries even though the battery's voltage is very low.
Okay.
Yeah.
Well, I appreciate you explaining that
Mhm.
to us. I noticed on this one too that you offering the PHP 3500. Could you go in a little detail and explain why you chose this particular power supply for
Mhm.
this project?
Yeah, sure. So this is for a humanoid, and it's similar to the previous one. I mean, maybe from similar companies, we don't know that. But yeah, as you can see, this is a 3500 watt unit. It's more than the previous UHP 2500. I guess because human needs more energy than a dog, maybe.
Right.
Yeah. So yeah, that's why the customers select the 3500 watt unit, and they want a fanless too, and they want water cooling. So our PHP can do this. We even offer water cooling plates, so they just hook up to their cooling system. And they need 120 and 240 as well because the customer is meant to sell their product globally. So they need the universal input,
Okay.
which this unit can do.
I get that.
And yeah, and also this unit support CAN bus, so I don't need to mention it again. You can set the current and voltage limitations. But one thing very important is there's something called EEPROM. So basically, when you set a parameter, let's say I want this voltage stay at 42 volts, and if we unplug the AC and plug it back, it's still 42 volt
Okay.
because the parameters are being saved into the EEPROM into the memory. So the power supply remembers. But for this particular customer, this is something they do not like. They want a power recycle to be reset. So every time unplug AC, plug it back, everything's gone. It's back to factory setting. So yes, we can do this. Well, and this doesn't even need a factory firmware. So all you need to do, and this applies to your customer too. If your customer needs the EEPROM to be off, they don't want to save the parameters, this can be done via CAN bus. So it's again also a simple byte flip, and that's it.
Do you find with most of these projects that the customers are using the standard off-the-shelf version, or do you find that in a lot of these projects, especially in this space, that you have to tweak or modify a lot of these power supplies?
Yeah. If the customer is buying like straight chargers, like our MPP series, they're smart enough. So normally they can just use an off-the-shelf product. But for like in this case, they're using a power supply, but they have some special requirements to make a charger. Then in this case, we need to do some modification to it to make it
Okay.
happen.
Okay,
Mhm.
great. Thanks.
Yeah.
Well, finally, a charger. I mean, on the NPB 1200, I've got quite a few projects that use the MPB series. Can you tell us a little bit about this product?
Yeah. So for this project, this is an MPB. This I think all of you should be very familiar with this our flagship charger MPB series, and f one thing special about this project is I mentioned the no battery detection protection earlier. You remember, right? The hot plug causes hundreds of amps, could damage everything for this specific customer, like they promised us, okay, we have our own relay, we have our own control system in between, and what we like to do is have Meanwhile charger always on. I mean, you don't need to protect us. We got us covered. We're like, okay, show us the proof. And so we communicated with the customer's engineering team. They showed us, like in general, what their setup is like and what happens when our unit is on. Their uh, like their device is plugged, and what's the capture of the waveform like. And when we evaluate, we were like, okay, this looks good. So you're not lying to us. Is you actually got it under control. So in this case, after the evaluation, we made a firmware change, a modification. We disable this protection so the output can be always on even without a battery. But like this is not something we recommend by default. But if your customer really wants this and they have evidence to show this is okay to do, then they're welcome to come to us and we will evaluate together and see what can be done.
Okay, very good. So I know right now the drone industry is pretty hot. Um, and I also noticed that quite a few of the manufacturers are utilizing our HEP series.
Mhm.
Is there a reason for that in this particular space?
Yeah, so HAP units is harsh environment. Yeah, harsh environment power. So for drones, like outside, they may be exposed to sun, there may be rain. So of course you want it to be reliable. You don't want the dust to get in the unit. So our HAP unit is power supply and also a charger. And in this case, because if you look at this diagram, and also the diagram is not like a real diagram because we don't want our customer to sue us. So this is like an AI generated like conceptual diagram. So the half unit will be enclosed in the dock because despite our unit is IP67,
Right.
yeah, but like we don't recommend a direct exposure to the sunlight because the color may change and the customer may not like it. It may think it's ugly. So normally we recommend our customer to enclose this into some sort of their own enclosure. In this case, the charging dock. And one thing very interesting about this project is still the customer wants to keep the AC always on.
Okay.
And it's different from the previous project. What we do for this is like we talk to the customer, we ask them to change a little bit of design. So whenever the drone is docked, before the batteries terminals connect to the charger, the drone shorts the remote on-off pin first. So the remote on-off is enabled first,
Okay.
and then the charger starts working. So this kind of avoid the hot plug situation, but like without any firmware modification from us. So it's pretty convenient.
Oh, thank you. That makes perfect sense. So here I see that you're offering the SHP 10K series. Can you explain also a little bit why you guys are using this power supply in this particular project?
Yeah, so for like large power, because before we were talking about residential, commercial, but now this is an industrial application.
Right.
Like this forklift, they have huge batteries, and we don't want to charge them in 1 amp. We want to charge them in hundreds of amps. And also, like in the industries, in the plants, they usually have 480 three-phase input instead of 120 or 240 single phase, split phase. So what we offer is our SHP 10K or 30K series. They have PV/PC function, so programmable voltage and programmable current. So the current and voltage can be adjusted, can be limited through an external analog signal. But of course, the SGP supports all the protocols, Modbus, CAN bus, PM bus. If that's something your customer needs, this is a go-to choice. But for this particular application, analog control is good enough. And also, we modified this firmware. We did some modification for both firmware and hardware level, so the output current can go boost up to 200 amp, but
Okay.
the output voltage drops to 42. And yeah, this is a fast charging for the forklift working in the warehouse.
Okay,
Yeah.
thanks. Hopefully everybody can see at this point that we have a very wide offering. Um, we have a very broad offering of different products. Okay, so lastly, to help drive people in the right direction, what are a few of the main questions that sales should ask their customers when choosing a Meanwell charger?
Yeah, sure. So when like a customer calls you, say, I need a charger, and there are a few questions you can ask them. The first one is, what's the battery chemistry? Like, okay, what battery you're using? Lead acid, lithium ion, sodium ion? And then the next question will be, what's the nominal voltage? 12 volt, 24, 36? And then what's the battery capacity? Like what's the amp hour? For example, the on the slides, you see this is our FT series battery. You see it's I think it's 30 amp hour. Then the charging that's something we need to consider because it's related to the charging speed, which is the next question. What's the maximum charging speed or what's the maximum charging current of the battery? And if you with the full information, you can start it to select the charger for us for the customer. Or there's a simpler solution. You transfer to engineer and that's it.
Very, very good.
Yeah.
Thank you. So lastly, we wanted to end this session by highlighting our virtual expo because we really feel it's a great tool. It's full of valuable information. We really want to ask everyone later today to, please log on and take a look at it. I think you'll find it to be a very valuable tool. And with that said, that kind of concludes our TechSpark for the day. Please mark your calendars. I think our next TechSpark, they're going to have a live training in the Kansas City office on July 16th, 2026. So contact your local Meanwell rep and request to attend.
Yes, this is an on-site training. Like some of you may have joined us in the New Jersey office, but this is the first time the tech training is held in Kansas City. So you're welcome to join.
Thank you again.
Thank
Thanks,
you.
Han.